How to boost Python speed with Cython basics. Learn to enhance your Python code performance by compiling it into C for significant speed improvements, crucial for high computational efficiency.
Welcome to our series on boosting Python speed with Cython basics. Did you know that Cython can make your Python code run up to 30 times faster? In this video, we'll explore how Cython bridges the gap between Python and C, allowing you to compile Python code to C for significant speed improvements. This is especially crucial for tasks that demand high computational efficiency and real-time processing. By the end of this journey, you'll be equipped to write and compile Cython code to optimize your Python applications. Whether you're in data science, machine learning, or game development, Cython offers a powerful solution to enhance performance. Before diving into Cython, let's get your environment ready. First, ensure you have Python installed. Open your terminal or command prompt and type pip install Cython. Next, it's a good practice to set up a virtual environment to manage dependencies. You can do this with Python mvend myaf, and activate it using source myaf/bin/activate on Mac OS Linux or myaf/scripts/activate on Windows. A critical step is ensuring a C compiler is configured. As Cython translates Python to C for Windows, we recommend installing Microsoft Visual C++ build tools. Verify your setup by running Cython version. Finally, create a basic Cython project structure with a .pix file for your Cython code. With these steps, you're ready to harness Cython's power.
Let's write our first Cython function. Open your .pix file and define a function like you would in Python using def. However, to leverage Cython's full potential, use cdf to define C functions, which allows for static typing, a key factor for performance gains. For example, cdf int add int a, int b, return a plus b is a simple Cython function that adds two integers. Notice the type declarations. They inform Cython to handle these variables as C integers, drastically improving execution speed. Understanding the subtle differences between Python and Cython syntax will help you write more efficient code. This example is a foundation to build more complex operations. Once you've written your Cython function, the next step is compiling it into a shared library. This is done using a setup.py file, which utilizes the distutils package to build the Cython code. Here's a basic setup.py from distutils.core import setup from cython.build import cythonize setup x_modules equals cythonize my_module.pix, run python setup.py build_x in place in your terminal to compile the code to a shared library. This command generates a .so file on Linux/Mac OS or a .pyd file on Windows, which you can import and use in your Python projects. Test the compiled library by importing it in a Python script and call your Cython functions to ensure everything works as expected. This process is crucial for achieving the performance boost Cython offers.
Enhancing existing Python projects with Cython involves identifying performance bottlenecks. Start by profiling your Python code to pinpoint slow sections. Convert these sections into Cython modules by rewriting them in .pix files and compiling them. The beauty of Cython is its seamless integration with Python. You can continue using Python's libraries and features alongside your Cythonized modules. For instance, if you have a data processing function that's slow, rewrite it in Cython, compile it, and replace the original function call. Gradually, your project evolves into a hybrid Python-Cython application, maximizing speed without sacrificing flexibility or functionality. This method is particularly effective in large-scale projects where rewriting everything in C is impractical. Let's dive into the performance comparison between Python and Cython. By benchmarking identical functions written in both languages, you can observe real-world performance gains. For instance, a loop-intensive function that takes 5 seconds in Python might execute in just 0.5 seconds in Cython. These gains are especially pronounced in scenarios involving numerical computations, data processing, or any CPU-bound task. However, it's crucial to understand that not all Python code will benefit equally from Cython. The speedup depends on the nature of the task and how much of it you can convert into Cython. Use visualization tools to graph these performance boosts, providing a clear, quantitative measure of Cython's impact. This comparison will help you make informed decisions about where to apply Cython in your projects. Transitioning to Cython offers numerous benefits, but it's not without challenges. A common pitfall is improper type declarations. Ensure your Cython code specifies types for variables to maximize performance. Another challenge is understanding the Python C API, especially if you're interfacing directly with C libraries. Compilation errors can be daunting, but often stem from missing dependencies or incorrect setup configurations. Maintaining code readability is crucial. Cython can become complex, so document your code thoroughly. Lastly, balance Cython's performance features with Python's ease of use, leveraging the strengths of both. By being aware of these pitfalls, you can navigate the transition smoothly and effectively. As Python evolves, so must your Cython code. To future-proof your projects, stay informed about the latest Cython releases, which often include updates and optimizations that align with new Python versions. Regularly monitor Python's version changes, especially if they impact core language features or libraries your Cython code depends on. Utilize Cython's compatibility features, which help maintain cross-version functionality. It's wise to test your Cython code across multiple Python versions to ensure robustness. Finally, leverage community resources and forums for support. The Cython community is active and can provide valuable insights and updates. By taking these steps, your Cython code will remain resilient and efficient, even as Python continues to grow and change.
Congratulations on reaching the end of this introduction to boosting Python speed with Cython basics. We've covered the immense benefits of using Cython to enhance your Python code's performance, crucial for tasks demanding high computational efficiency. I encourage you to practice writing and compiling Cython code to cement your learning. Join the Cython community to stay updated and get support as you explore more advanced features like memory views and parallel processing. Don't stop here. Subscribe to our channel for more tutorials on optimizing your code and expanding your programming skills. Thanks for watching, and happy coding!